Hey everyone, Mr. Aaron's again. Um, Today we are on to lesson 4.2. As I talked about yesterday, we're going to work on exponents a little bit. Today we're going to need to do them. We've talked about them in our PEMDAS. We're going to practice them in our PEMDAS. As we know in our PEMDAS, they come second. We got parentheses, then exponents, then we got our multiplication, division, addition, subtraction. So it's going to be our second step. We're going to get some working with that today. Let's get after it. So, an exponent. You've probably seen them before. What it is it is repeated multiplication. It can look like this. It could be 2 to the 4th. It can look like this. It could be 7 to the 100th. It could be 8 to the 90th. It could be 6 to the 7th. All sorts of things like that. Basically what happens is we have three parts. Our whole thing is called a power. You maybe heard that before. Something like this one would be called 2 to the 6th power. 2 to the 6th power. Our base number is what we say first. That's our 2. 2 right here is our base. Our exponent is 6. 2 to the 6th power. I would say this one is 2 to the 4th power. 7 to the 100th power. 8 to the 90th power. 6 to the 7th power. And what is that? Well, all of those are telling us is it's saying take the base number and multiply it by itself. Multiply by itself. I'll write that over here. Multiply by itself X amount of times. Multiply by itself X amount of times. So we're going to take 2, multiply by itself 6 times. So we're going to do 2 times 2 times 2 times 2 times 2 times 2. And I'm going to use a lot of my calculator today just so I can make the lesson a little faster. I'm not going to have to do all of that in my head. So I would do 2 to the 6th power, or 2 times 2 times 2 times 2 times 2. I would get 64 for that. Another way you can do it, if you're looking at a calculator, you'll see an option. Usually it looks like a little button that's pointing upward. 2 to the 6th also will give me 64. Both those are options if you're looking at a calculator. Okay, so we know we got our power, which is the whole thing, consists of the base and the exponent. Our exponent is the little number. Our base is the big number that is being multiplied. All right, let's get some working with it. So I have a little example here. I have our diagram, and then I'm going to write it out, and then I'm going to write what they would equal to. So our first one I already did for us. We have 12. How do we say this out loud? 12 to the first power. 12 to the first power. I wrote that one out, and that would be 12 times itself 1 times. So that would just be 12. Perfect. Next one, we have 6 to the, probably thinking, second power. To the second power. And what would that look like? That would look like 6 multiplied by itself 2 times. 6 times 6. I already know that one off the top of my head is 36. 6 to the second power is 36. 6 multiplied by itself 2 times. Our next one. This one's a little tricky. This is where it gets a little different. The negative is sitting on the outside. So we're going to do our order of operations. We're going to do our exponents first here. So this is the opposite of. That's because it's going to turn negative at the very end. That's going to be our last step. The opposite of 7 to the 4th power. What this is going to look like is we have a negative sitting on the outside. On the inside, we're going to have 7 times 7 times 7 times 7. 4 times. I'm going to punch that one in my calculator to save some time for us all. And we get negative 2,401. That's 7 times 7 times 7. I have that negative sitting on the outside, so I know I'm going to multiply that at the end. Negative 2,401. Our next one, look at the negative is on the inside. Pay attention to that. That is important. The negative is on the inside this time. That means we are going to have negative 8 to the 5th power. What is this going to look like? Equal signs there. It's going to look like negative 8 times negative 8 times negative 8 times negative 8 times negative 8. 5 times. Negative 8 times itself 5 times. Punch that one in. We got to remember every time that we do a negative, it's going to change back and forth from positive to negative. So for example, if I had negative 8 to the second power, it would be negative 8 times negative 8, which is going to be a negative times a negative, which is going to be a positive 64. But if I have negative 8 to the third power, it's going to be negative 8 times negative 8, which is going to be a positive, times one more negative 8, which is going to be a positive times a negative. These two are going to be a 64, times a negative 8 would be a negative answer. So you got to pay attention. Usually if you have a negative, and it's an even number, it's going to be a positive. If it's an odd number, it's going to be a negative. Just pay attention to those as you're doing your multiplication. All right, now I did the opposite. I gave us some problems here, and I'm going to try to reverse them, and we're going to write them as powers. So we have negative 5 times negative 5 times negative 5. So what this really means is we're doing negative 5, that's going to be our base, times itself how many times? 3 times. That's our exponent. Oh, I just realized this whole time I've been using my purple marker, and I would like to be using my red. I'm going to switch up right now. Don't let it confuse you. We're going to do negative 5 3 times. 1, 2, 3 times it by itself 3 times. That's our power right there. Okay, here's where it gets a little tricky. They give us negative 2 times A times B times A times A. Our order is a little mixed up. But if we remember, we have our commutative property of multiplication, which means we can rearrange this however we want. So I'm going to start by rearranging it right as negative A or negative 2 times B. I'm going to put all of my A's by each other. From here, I can take my next step, and I'm going to simplify this. I see I have negative 2 times B, and then I have A times A times A. What is that going to be the same as? A times A times A is A multiplied by itself 3 times. So watch what I'm going to do. I'm going to do negative 2 times B. I know those can touch because that means the same thing. Times A to the third power. A 3 times. We left our negative 2. We rearranged just so I can make it look a little easier. You didn't have to do that step if you didn't want to. Negative 2 times A times B times A times A. Rearranged to make it negative 2 times B times A times A times A. 3 times A's in a row. That makes it A to the third power. A times itself 3 times. Take a look at our next one. We got 6 times 6 times 6 times 2. Well, I know that 6 times 6 times 6. I can write that as 6 to the third power. 6 times itself 3 times. Times 2. We could actually solve this if we wanted to. I'm not going to worry about that for now. But we could do 6 times 6 times 6, 216 times 2. Our answer would actually be something like that. All right, and I got one more for us, number 4 here. 4 times y times x times y. I'm going to start by rearranging. I got that commutative property of multiplication. I'm going to make it 4 times y times x. Got those y's next to each other. Now I see 4 times y to the second power, y times itself twice, times x. I know it seems a little confusing. You just got to count all those up and put it to that power. We'll get some more practice. Don't you worry. All right, now we are going to simplify a power. We're going to undo what we just learned how to do. A microscope can magnify 10 to the third power times. How much is that? Well, I know that that really means 10 times itself. How many times? 3 times. 10 times 10, I know that's 100. Times 10, add another 0. We're multiplying, it's magnifying 1,000 times. 10 to the third power is the same as 10 times 10 times 10. All right, next one, they give us simplify 7 to the second power. What does that mean? That means we're going to do 7 times itself 2 times. We know how to do that. Easy peasy. Oh, here we go. Moment of truth. The PEMDAS is coming in. This problem is tricky right here. So they give us 2 different problems. They give us negative A, I'll write it down here actually, negative a to the fourth, and they give us negative a in parentheses to the fourth. And they tell us for a equals 0. I remember what this means right here is I'm going to plug in a equals 2, excuse me. I'm going to plug in for every a I see, I'm going to plug in 2, so I'm going to start by doing that right now. There's one of mine. There's the other one of mine. Start with our PEMDAs. We know on this side that means parentheses. It's all connected. On this side we don't have parentheses, so we're going to start with our exponents. So let's look at this side first. We're going to start with our exponents. So it's going to look like this. We leave the negative out for now. It's not in the parentheses. It's sitting outside. If you want to make it easier for yourself and make an imaginary like this, or you could even do an imaginary like this too. That works just as well. It's going to be a negative 2 times 2 times 2 times 2, 4 times. And then the negative sitting on the outside. Punch that one in. 2 times 2 times 2 times 2. And there's the negative sitting on the outside. So I know this one is negative 16. Check that out. Negative 16. So negative a to the fourth equals negative 16. Okay, there's one answer. Now we've got this one over here. We have negative 2 on the inside. So what this is going to look like is negative 2 times negative 2 times negative 2 times negative 2. Look at how those are different. This one has the negative sitting on the outside multiplied by regular 2's. This one's a bunch of negative 2's. Watch how this is going to change things. Negative 2 times negative 2. That's two negatives. That's going to make a positive. Times another negative 2. That's going to be back to a negative. Times another negative 2. That's going to bring us back to a positive. So when we have that in the parentheses, it changes the problem. Makes it a positive 16. Pay special attention to problems like those. Okay, on to our order of operations. We got to think about our PEMDAs here. Our exponents come second. Super important. Let's get into it. They give us 4 times 3.7 plus 2 in parentheses to the second power. We're going to start with our parentheses. We're doing our PEMDAs right in order. 3.7 plus 2 is going to be 5.7. I'm going to rewrite this. 4 times 5.7, second power. Next up is our exponents. It's our time to shine. Let's do those exponents first. I'm going to rewrite this as 4 times 5.7 times 5.7. Times itself 2 times. Punch that one in on my calculator. We got 32. 4 times 32.49. And finally, we get a solution of 129.96. We followed those PEMDAS rules. We started with our parentheses. From there, we did our exponent, our 5.7 times 2. And then we went on to our multiplication. Follow those PEMDAs. That's going to be super important in today's lesson. Number 2, they gave us negative 2 times x to the third plus 4y. They tell us for x equals 2 and y equals 3. What are we going to do with these? Well, we're going to plug them in. Take that, plug it in there. Take that, plug it in there. Let's rewrite. Negative 2 times 2 to the third plus 4 times 3. Start with our PEMDAs. First up, parentheses. Parentheses are already solved. Next up, exponents. I got one right here. Let's do it. Negative 2 times 2 times 2 times 2. 2 to the third power, that means 2 times itself 3 times. Plus 4 times 3. Next up, we're on to our multiplication. We're going to do it from left to right. Negative 2, let's do 2 times 2 times 2. We got those in parentheses. That would be 8. So we got this as negative 2 times 8 plus 4 times 3. Negative 2 times 8 is negative 16. 4 times 3 I know is 12. Our answer here is going to be a negative 4. Follow those PEMDA steps, you'll get negative 4 for that. Plug those in, start with our parentheses, move on to exponents. From there, you know the rest. Last problem, I'll get you working here. We got 2 times 5. I haven't talked about this yet. So this is 5 to the second power. You can also say this as 5 squared. Whenever it's a 2, sometimes people will say that as squared. Today we're going to practice saying it as 5 to the second power, but just know that that can also be said 5 squared. So we have 2 times 5 to the second power plus 4 times negative 3 to the third power. Let's do our PEMDAs here. We got 2 times parentheses first. We only have 1 right there. It's already solved. Next up is our exponents. We've got 2 sets of exponents. So we're going to start with this one. 5 times 5. 5 times itself 2 times plus 4 times negative 3 to the third power, which is going to be negative 3 times negative 3 times negative 3. Okay, back to our parentheses. This is 25 plus 4. Negative 3 times negative 3 is going to be negative 9, or positive 9, excuse me. Negative times a negative. Then we're going to do that times a negative 3. 9 times negative 3 is going to be a negative 27. Our last step, hit that multiplication. This one's going to be 50 plus, let's see, 4 times negative 27 is going to be negative 108. 50 plus a negative. I have more negatives than positives. I know this is going to be a negative number. Negative 58 should be your answer there. Follow those PEMDA steps. There's my bell ringing. It must be telling me to end my lesson. Good luck with your homework today. Email me if you have questions.